Okay, so we have the first talk by Zheng about fisher meat.
Uh, so hi everyone. Okay, this is a joint work with my with Yixing from Sufi. We are going to talk about a unified duality framework for market equilibrium. So I just cut through our topic. Is market equilibrium is where we wish supply meets demand through prices. Like everyone gets their favorite kind of allocation of goods. So some notations, like I will assume there are n agents and M divisible goods, and every agents, they come in with a budget. They don't have value. They want to spend their all budget and get some goods, and they have a utility function representing their preferences on the goods. And there's a kind of in fact, in this session we have 3 talks on future market. So just introduce it. It's important framework where it's concerning about allocating private goods. Private goods means this is like a unit supply of every good, and everyone will receive a separate bundle of goods. And we're doing so such that through prices means we will put a price on the every good, and everyone just trying to buy like using their budget, their favorite bundle. And at equilibrium means everyone gets their favorite bundle, and every goods is sold. So supply meets demand, and everyone's happy. There's a less well-known, I think, framework called Lindo market, where the goods here are not private; they're public. What does it mean? It means like considering, say, we have 10 people and we want to decide what do we have a total budget of let's say 10 like 1,000, and we want to spend on certain things like okay. So okay, consider another example. Like in a city, we want to spend a funding of say 10 million on the in the city. Like we can spend on hospitals, we can spend on schools, and people have different preference. Someone we should spend more on the schools or something else. And the important thing here is that the allocation is public, means everyone will receive the same allocation, because if I put some money on school, everyone can access it to some extent, but still like they have different preferences. And we want to achieve an equilibrium where everyone is satisfied by using personalized price, means everyone pay a personalized tax kind of for each public goods. And okay, I think the main question in this talk is like for econ and CS, it's really on the existence, efficiency, computation, and dynamics for market equilibrium. Like, are they exist, and can we compute it? Are they like have good welfare? Like, can like a natural like decentralized learning dynamics converge on market equilibrium, and like the price will finally adjust to the kind of the right price that supply meets demand. Okay, to like before like I talk more on this topic, like on the computation, like I will introduce more like exactly what is two equilibrium. So the Fisher equilibrium, as I said, is like consists of allocations. So everyone receives a bundle, xi here, and we have a price p, and it is an equilibrium if the bundle xi everyone agent receives is affordable. Okay, their budget can buy these goods. And this utility maximization means under this price and the budget constraint, everyone is buying their optimal bundle, like maximizing their utility. And the market clears means every good is sold. In the Lindo case, okay, if you look at it, it's like a slightly different, right? Because now we have PI, which is a personal price, and an X, which is a common allocation. Still, like it should be affordable. Everyone can afford these public goods, and it is utility maximization. Under the personalized price, everyone agrees on to buy this bundle because it maximizes their utility. Could be different utility for everyone. And it's okay. The third condition is called profit maximization. I will not explain that clearly here. It's really like assuming there's someone also like producing the public goods. They also want to maximize profit. After some reformulation, is this kind of inequality here. Okay, and both equilibrium are very good. So first, they're all little optimal. And for future market, it's also envy free because everyone already gets their favorite bundle, and it achieves many nice properties, has many applications. For the less well-known, I will emphasize on the less well-known Lindo equilibrium. Okay, imagine that everyone agrees on, okay, despite their kind of diverse preferences, they all agree on buying something the same, right? So it's like it has many applications in collective decision making. Well, people have different preferences, but they want to agree on one decision that everyone agrees on. In field division, donor coordination, AI alignment, I just put some reference here, like using Lindo equilibrium in both economics and computer scientists. Okay, and okay, I will quickly introduce some utility function. Like, imagine that. Okay, I think you just need to remember, like, we are kind of, well, in this talk, I'll consider like two utilities. One is additive, like it's linear utilities, means every good has some utility to you, and you just add it up. And one is like a complementary utilities. The lineative utility means you must buy every good you must receive certain amount to divide utility, because if you only have say something but not anything else, it doesn't have any utility to you. And the Nash social welfare is defined by the product of every region's utility weighted by their budgets. Okay, why I introduce Nash social welfare? Because it's very very important to all the questions that we want to solve. So in the special case of the linear utilities, there's a famous program called Eisenberg-Gale program. What this program does is really like it wants to find an allocation, maximize the national social welfare. It has no constraint on how it should be like utility maximizing for every agent or something like that. It just finds allocations that maximize social welfare. And you can write a dual or dual program. It's called Shamrath program. Why is it important? Because an allocation is a Fisher market equilibrium if and only if the allocation solves e.g. Fisher-Lindo program. So it implies all these nice property we want, right? Existence, because yeah, it's convex program has solution, so we have a Fisher market equilibrium. And efficiency, by definition, it maximizes national social welfare, and we can compute it efficiently by solving the convex program. Dynamics, in fact, like there's a natural proportional response dynamics, decentralized. It can be proved to be to have a nice convergence because it's equivalent to running an optimization algorithm called mirror descent on this Shamrath program. And importantly, all of these nice properties generalize to CES utilities, not only linear. I can just put linear here, but you can imagine the program can be generalized to other utilities and even more general, also concave homogeneous utilities. And how about Lindo equilibrium? Okay, it's like for the linear case, we still have these nice results. Like you can see everything here is very similar. We just want to find one allocations X here to maximize everyone's maximize the total Nash social welfare. It's still a convex program, and you can still write a dual, and also has characterized like an allocation is Lindo equilibrium if and only if it solves the e.g. Lindo linear program, and then like by the same argument, you have all the nice properties, right? But importantly, is like first, okay, so the Shamrath program is proposed just last year, like 2025 by Kroll and Peters, and all like kind of the nice results are known only for this linear utility case. Like, why not more general, right? They all look similar, right? Kind of the results. Why not there's another EG program or Shamrath program and should hold even more generally, right? But yeah, so kind of is asking this question, like, is Lindo equilibrium kind of different or harder than Fisher equilibrium? Like, I would just give you like two sets from economics and computer science. They are saying that they're quite different. So, as like in this BGSS papers, they will say, oh, like Fisher market is connected to national social welfare. It's very well understood. But in public goods, because the goods are public, no, the relation is quite volatile. Does not hold in general. And by KP, they would say, oh, the two convex programs has important structural differences. And it's kind of unknown like how to generalize them to nonlinear utilities. Indeed, if you look at the two programs, they are really different. If you look at the left, like the Fisher program, it has only variable constraints only on the prices, and it always has a rational solution. On the right, in the Lindo case, it only has variable and constraints only for the allocations, and it may have only irrational solutions. So yes, I agree. Like it's pointed out by the KP paper, yes, we are really like different, but it's bad for us, right? So it means like we need to develop kind of new techniques, and it seems like we need something new to to recover or like reproduce any results we know for the future case in the Lindo market setting. So what we argue in this paper is that if we take a duality perspective, in fact, we can reconcile this difference. So we should not look at Fisher linear with Lindo linear. In fact, we should look at Fisher with another type of utility. Is lineative, like from linear is like a purely substitute utility. We should look at a purely complementary lineative utility. If you write down the schema of Fisher lineative utility, what do we notice here? In fact, the two programs are exactly the same. The only difference is that the variables in the Fisher, like in the bottom left, it has only kind of constraints on P, which is the price. And on the right, on the Lindo linear, it has constraints only on the allocation on the X, but it's like just a notation change, right? Everything else is the same. So every solution in the Fisher lineative case is also a solution in the Lindo linear case, but the role of allocation and the prices has been exchanged. We have three insights on the duality. It is a duality between private good and public goods. And it's a duality between complementary utility and substitute utility. And this duality kind of works by exchanging what we compute in the Fisher case, a price. The equilibrium price become an equilibrium allocation in the Lindo case. What else, like a kind of general result beyond this linear lineative duality? Can we say more like how does duality works? So the duality, in fact, it works by the indirect utility function. So it's like for any given utility function, may not be linear or whatever. It's just a utility function and a budget. You can define the indirect utility, which is defined as kind of under this price, what is the maximum utility I can get under the budget constraint? And the dual utility is defined by the inverse of the indirect utility function. So if you do some, okay. So some examples, the dual of a linear utility is indeed a lineative utility and vice versa. And the dual of a CES utility with a kind of parameter rho is another CES with another parameter, and every complementary CES will become a substitute and vice versa. And we can prove a fundamental duality theorem under like a mild assumptions. The following two conditions on X, P are equivalent means under this price P, X maximized utility subject to the budget constraint is equivalent on the dual utility under the price of X, P maximized utility. It's like really exchanging the role of price and allocations. And our main results looks as follows. So for any public goods Lindo equilibrium, you can define a private good Fisher market with the same agents, same goods, same budget, but with dual utilities defined, I just defined. Then PIX is a Lindo equilibrium for the Lindo market if and only if X tilde I and P tilde I is a Fisher equilibrium for the dual market, and X tilde I and P tilde I are just by exchanging the role of allocation and the prices in the previous defined Lindo market. So the proof is very simple by definition, by the duality theorem, and by the role that we exchange. And it's like you can verify that just by a few lines of calculation is exactly equivalent. And it's important that, okay, first, the other direction also works. You can also reduce a Fisher to a Lindo, and the condition are very mild, covers all CES and even much more. And we are the first kind of to establish existence of Lindo equilibrium. Also in the literature, someone used similar argument also to establish existence. And I will just quickly talk about applications. So for concave homogeneous utilities, Lindo maximize social welfare. For non-homogeneous, they are not maximizing, but we achieve tight approximation. I can introduce new total complements as the new checkable solution utilities, and we propose market dynamics. And importantly, our duality firm also works for market with choice, where the items are not goods. They incur like a negative utility to the agents. We propose programs, and we also are the first to study how to allocate public choice by using duality, because we always write a duality and studies as a setting. So in conclusion, we present a duality framework that unifies Fisher and Lindo, I think importantly, it allows one to transfer any results from one setting to the other and inspires new notions and new results. For future directions, I think it's important to consider like a market with both private and public goods and the linear equilibrium with funding caps, which you consider in the KP paper, and it's important in practice, and also how to allocate public results. We only have preliminary results. Thank you.
Any questions?
What's the question? Okay, so I think it's quite different because I think you can imagine that you like as a fair division, like a fair division with goods and trusts are usually not exactly the same. But I think it's the same thing here. Like for example, you cannot write an EG program, say kind of you cannot maximize the utility, right? It's like you want to minimize this utility. And in that case, really like you cannot have a convex program that characterizes the optimal solution and the equilibrium here. Yeah, the program will be a non-convex program. Thank you.